Today we start our topic on sequences. Now a sequence is just a set of numbers that has some kind of pattern to it. So today we'll start by looking at the notation for sequences so that when we're talking about different parts of a sequence, we're all using the same terminology. Now two different types, a sequence could be infinite, meaning that it goes on forever, and you'll see that by seeing some dots at the end of the sequence. Or it could be finite, meaning that it just has a set of numbers and then it finishes there. Now we use the big capital T to stand for term. So that if we're referring to the first term or the third term or the fourth term or the second, whichever one, we can put a little number there, T1 being the first term, T2 the second, and so on. So we see this really frequently, Tn, and this means the nth term, so that no matter which term we're thinking of, often we'll have a little formula for Tn that helps us figure out any term in a sequence. Now there are three conventional ways that you can specify a sequence, that is, describe it. You could simply just write out a number of the terms to show the pattern. So I've got a sequence here that goes on forever, so it's an infinite one, 5, 7, 9, 11, 13. A quick glance and I can see that I'm starting at 5 and I'm going up throughout the odd numbers, going up 2 each time. Now you could specify this exact same sequence by just giving a formula for any one term. Let's call it the nth term. So how did I come up with this formula? Well, this specifies the exact same thing, because if we say, all right, well, using this formula, what would the first term be? If I sub in 1 to get T1, I've got to do 2 1s, that's 2, plus 3, I get 5. So a quick inspection of this tells me the first term's 5, same as this one. The second term, well, if n is 2, we've got 2 2s at 4 plus 3, that would give me 7. And you can see with this formula that every time we go up a term, we have to double the number of the term and then add 3. And that's exactly the same sequence as this one, just expressed a different way. Now, we can also express a sequence by just telling where to start. If we give T1 and say, well, for example, with this one, start with T1 being 5, that's the first term. And then if we let people know how to proceed from there, by giving them a formula for Tn, not one of these ones that works for any term, but a formula just for the second term and onwards, because we've said the starting point, and then we say how to go on from there. And this third method of specifying a sequence says, well, we're going to give a formula for Tn, but we're only going to let you know how to find each term from the one before. Now, this is called a recursive formula, because it relies on knowing the thing that came before to be able to work out the next one. So if you look at this formula, this is exactly the same sequence as what I've specified in the earlier two examples here. We're saying the first term's 5, but then if you want to find any term after that, say if you want to find the second term, well, sub 2 in here, 2 minus 1, they say start with the first term and add 2. If you want to find the third term, put 3 in here, that would be the second term plus 2. The fourth term would be the third term plus 2. So all three of these have their advantages and their disadvantages, and you should be able to specify any sequence in any one of these methods and convert it to either of the other two. The advantage of this one, you can clearly and easily see what the terms are, and as long as you can spot a pattern, that's quite helpful. But the disadvantage is you haven't got a simple formula to jump straight to. If I said, what's the 120th term, it'd take you a minute to figure that out. This would be a great way of finding the 120th term really quickly. Plug 120 into the formula, double it, 240, and add 3, 243. So this way of specifying a sequence is fantastic for finding individual terms quickly, but it doesn't give you that straight away at a glance ability to just see what the pattern is and what the sort of starting numbers are. You'd have to investigate it and it'd take a little bit longer. This last method is fantastic if you have a term and you want to know what the next one is. You can quickly and easily see, oh, we just have to add 2 each time. So we're starting from 5 and we're adding 2. But like this one, if I wanted to quickly and easily find the 120th term, I'd be a bit stuck with this one because I'd be thinking, well, hold on, I need the 119th term to be able to find the 120th term, and that would be its limitation. So you can see why if you're given any one of these, being able to transfer to one of the others could help you solve a problem.